outline of everything. So before we start, I'm going to give a quick outline of what I'll be talking about today. So first, I'll give a more in-depth intro and for myself and show everyone all the exciting lessons that I have planned for this summer. I'll then go over the classroom expectations, which is very brief, so don't worry about that. And I'll move on with going to our lessons for today. And finally, we'll have a short Q&A session for anyone to ask whatever questions they might have. So let's get started. So as Jack mentioned, my name is Jamie and I graduated from Colonel By Secondary School in Ottawa. I'll be attending the University of Waterloo in the fall for computer science. So that's very exciting. I was also in the IB program at Colonel By and I took the HL math course or higher level math course. So if anyone has any questions about that, if they're going into high school right now or the IB program, I'm free to answer any questions about that during our classes. So at Colonel By, I was a math club executive and I taught members weekly lessons to prepare them for math contests. And it's kind of like what we're doing here. So yeah, I'm also interested in programming. So I was a part of computing club and I competed in the VEX robotics competition. So with regards to my teaching experience, I was a student organizer for a math circle, as Jack mentioned, and that's a local community organization that prepared students for CEMC contests. So while I was doing this, I prepared a group of around 30 grade 7 and 8 students for the Gauss contest. I also have considerable experience with contests. I've been participating in CEMC contests, in particular since grade 7, and since I just finished grade 12, I have recent experience as well. So I'm here to give you guys tips and strategies to help you guys succeed with contests as well. Yeah, the formulas and equations that I hope to share with everyone throughout the course, as well as the critical thinking skills that I want to help you guys develop. I'm sure that those will help you save valuable time during contests. Yeah, time is a very important thing during contests. So it's important that we can solve questions quickly. And I think that the tips and tricks that I'll share will definitely help with that. Okay, on to the class schedule. This Pascal class is supposed to run from 3:30 to 5:30 every Monday to Wednesday from July 5th to August 4th. So these are all the lessons that I'm hoping to go through with everyone during this course. And so today, starting with the open lesson on top, today's lesson is patterns and sequences. So that's great. During lesson 1, I want to help everyone become very comfortable with word problems since that's super important for CEMC contests. I'll then cover factorization, primes, divisibility as another part of your foundation. Then during class 3, I'll cover counting and probability. So counting, even if it seems very simple, we've known how to do it since most of us have known how to do it since we were very small. But in contests, we need to make sure that we count very accurately and very efficiently so that we don't miss different cases or we don't run out of time. That's why I wanted to have a class to focus on that. With regards to probability, it's also something that the students that I've taught and something that, the students that I've taught have struggled with. So maybe you guys do, maybe you guys don't. But in any case, I'd like to cover how to not miss different cases and how to get the correct answer. For lesson 4, optimizations and inequalities are also important. So you might be asked during a CEMC contest to maximize or minimize any values. And it's also applicable to real life where you might be asked, where you might want to maximize your profit or minimize the amount you have to pay to someone else. Okay, next for rate problems and percentages. This topic is also something that I've found really important, and students often struggle with these kind of problems, but I hope to help you guys improve with this. Then for lessons 6 to 8, I wanted to cover geometry, particularly 2D, 3D, and coordinate geometry. So during this, I'll share many tricks and tips that have been super helpful for me, at least. Am I on time? So week 9 is games and logic. So game style questions appear very frequently on CEMC contests, and they require like a lot of logic to understand. It's less number crunching and more strategic thinking. So I find them very interesting. It's a different kind of problem. So once you solve, one other thing about these kinds of problems is once you find that strategy and you figure out how to like always win at the game, you have like a feel good moment and feel like a sense of mini accomplishment. So for the last session, I wanted to go over some problems that I found interesting for the Pascal contest. And I also wanted to give a few more pieces of advice to help everyone prepare for the contest on the last session. So yeah, depending on how much you guys know and how big our class is, I'd love to adjust the schedule, but this is the plan for now. So yeah, one last thing before we get into our lesson, expectations. So yeah, not that scary. I don't have too many rules. First, as a given, I want everyone to respect everyone else in the class. We might not all be in the same place, so I do ask that everyone follows this rule. Next, I want everyone to hopefully participate and feel free to ask me any questions that you guys have. So yeah, don't hesitate to do that. You should also let me know if I'm going too fast or too slow. So yeah, just any feedback at all would be amazing. You guys can do so by putting anything in the chat or by raising your hand or whatever the Zoom equivalent is for that. And last rule is have fun. So even if it is a class, I think that math competitions can be very fun. And yeah, you guys can all apply your knowledge and yeah, succeed with math contests, all a good time. Next, regarding homework for this course, I want to assign optional homework for you guys to do. And I say it's optional because I don't want to force you guys to do homework, but I want to give you guys the option to practice on your own at the same time. Yeah, I want to like really stress that practice is really important to help you guys improve your math skills. Like you need to learn and then also spend some time on your own thinking about it so you know how to apply it during a contest. And I also think it should be optional since your improvement really depends on how much you want to improve and how much work you're willing to put in. It's also a matter of like how well you learn and knowing the way in which you learn best. So some people don't like homework, and that's up to them. If they have a better way to learn, then I'm all for that. But yeah, again, like the more you practice, the better at problem solving you'll get. And eventually, once you see enough problems and you've solved enough problems, you'll be able to think about steps to solve the question once you start reading the problem. So yeah, since homework is optional, during the next class, we can always go over anything you guys had trouble with, or if you guys chose to do another problem for homework or like some other problem that you found during practice, we can always go over that. So if you had any difficulties or just a quick question, no matter what, we can always go through it as a class. Really, I just want to make the best use of our time as a class to help you guys prepare for Pascal. And yeah, any math related questions are definitely welcome. Yeah, for this class, no homework though. I'll start by giving the optional homework next class. Okay, that's it for expectations, and on to our lesson for today. So we're doing patterns and sequences, very exciting. This is a very common problem on CEMC contests. You might be asked to find something like you might be asked to do something like find the 2021 term in the sequence. Just a side note, CEMC does like they like adding the year in which you write the year, the contest year, in many of the problems. So one quick contest strategy that you guys can do. Since next year is 2022, since we're preparing for the 2022 Pascal, it's always good to know little properties about the year that you're going into. So for example, is 2022 prime? If not, does it have a factorization? Obviously, since it's even number, it's not prime. But yeah, that's just something that you guys should be aware of. And one little trick that you guys can take away from this. Anyway, so on to definitions for patterns and sequences. A pattern is a repeated arrangement of numbers, shapes, or colors. And for an example of a pattern is red, yellow, blue, red, yellow, blue, red, yellow. And since it's a pattern, I'm sure you guys all have recognized this by now, that the next term in the sequence, in the pattern, sorry, is blue. Next, sequences are ordered lists of objects. And in this case, they're usually numbers. So one example is 1, 3, 5, 7, and then, yeah, so on. I'm sure you guys have all recognized already that this is a sequence of odd numbers. So the next term would be 9, 13, and 9, 11, 13, and so on. One more thing, vocabulary that is quite important for patterns and sequences. First off, periods are for repeating sequences only, and it's essentially the how many terms are in the part of the pattern that repeats itself. I'll have examples on the next slide. Another piece of vocab is iterative. So if a sequence is iterative, then you can generally use a formula to reach the nth term, which just means like any term in the sequence. Recursive sequences, on the other hand, by the way, recursive and iterative sequences go hand in hand. If it's iterative, like it could be either iterative or recursive. So yeah, recursive sequences use a previous term to get to the next term. And I'll show you guys an example on this slide. So here we just have a few examples of all the vocab that I introduced on the previous slide. For example, in the sequence 1, 2, 3, 1, 2, 3, 1, 2, and like so on, it continues, the sequence continues. The period is 3, since 1, 2, 3 is the part that repeats, and it has three terms inside that, inside the little repeating chunk. Next, iterative. So in the sequence 3, 5, 7, 9, you can find that there's a rule to get to any of the terms, and you can do this by plugging it into that this formula here. So fn is equal to 2n plus 1. If you guys haven't been introduced to function notation, then don't worry, we will cover that. But yeah, this is the rule. So if you plug in, if you want to find the first term, you plug 1 into this equation. So 2 times 1 is 2, plus 1 is 3, and then you get the first term. Then you get the first term, and as you can see, then that is what you get for the first term. And same thing with any number of terms. So that's what an iterative sequence is. And next, for the recursive sequences, where you use one of the previous terms to get to one of the next terms. One of the most famous examples of recursive sequences is the Fibonacci series sequence. And I'm sure you guys are all familiar with this, but it just goes 0, 1, 1, 2, 3, 5, 8. So you add the previous 2 terms to get the next term. And so yeah, that's the rule for this recursive sequence. Okay, on to a few tips and strategies for patterns and sequence problems. The first thing that I do whenever I encounter one of these kinds of problems, I always try to look for a pattern. And so if I don't see a pattern, then I'll continue either trying different, like looking at the problem through different approaches, or I'll keep on generating more terms of this sequence to see if maybe the pattern appears later on. An example of this is like maybe the period is really large. So if the period's like 10 terms, you won't really see this on a CMC contest, but if the period were really large, then you would need to calculate more terms to find that pattern. You would also need to ask yourself a few questions. I like to ask, or like, it's kind of something that you think of intuitively. So you'll think about this on your own eventually after you see enough of these problems. But something that I like to ask myself is, maybe, is it ascending or is it descending? Then I'll use addition and multiplication, or subtraction and division respectively. The other option, the last option, if it's not ascending or descending, it's just constant. It's not a very interesting problem, so you will likely not see it ever on a CEMC contest. Yeah, and then some patterns that you can look out for are arithmetic or geometric sequences. And these, arithmetic is just adding and subtracting, and geometric is multiplication and division. You can also look out for repeated sequences. Yeah, I talked about like periodic sequences before. So just when the numbers repeat itself and it keeps on looping around in that period. Okay, problem 1. We're doing pretty good on time. So yeah, I'll just read this problem. It's from the 2016 Pascal, and it's problem 11. Okay, so the oblong number is the number of dots in a rectangular grid with one more row than column. The first 4 oblong numbers are 2, 6, 12, 20, and are represented below. So as you can see here, the first rectangular grid has 1 row and 2 columns. Sorry, 1 column and 2 rows. The second term has 2 rows and 3 columns, and so on. By the way, I think it's a good time to take a little pause. Does anyone have any questions so far about anything that I presented? If you guys want to either unmute or share something in the chat, I'd be fine with that. If I can find the chat window. Okay. And if not, oh, I think we can only DM the host. Okay, never mind then. Okay, I'll assume that nobody has any questions in that case. But if you do, then feel free to interrupt me. I'll be using the whiteboard feature on this. Let's see, can I use the whiteboard feature? Annotate, okay. I'll be using the whiteboard feature to just draw on this for a little while. So as you can see here, I'm just going to be drawing how many rows and columns each one has. So we can see the pattern here. Oh, okay. So, okay, so as we already got from the problem that each rectangle has 1 more row than column. So as we can already see that here, that there's 1 more row than column. So 1 plus 1 is 2, 2 plus 1 is 3, so on. We already know that. Then upon closer, we have to like look at the problem a bit closer. So we're looking for the number of dots over here. So what this translates, like when I read it, I think, oh, the number of dots, that just means area, because that's what the number of dots is essentially. It's like the area of the shape. So in that case, we already have the areas over here. But yeah. So since we know that since we know how the length and width are related, then we can know we can find a general formula for the area. So in this case, if we're looking at the ends, this is the term. So if we just imagine that this is the term number, we say this is 1, that's 2, this is 3. Oh, here, I guess it's already written there, and that's 4. We can say that if this is like our n, then we can say that the formula for the area is Fn, and to get the area, it's length times width, right? Length times width, or n times n plus 1. So like the length would be like the column, yeah, the number of columns, and then the width would be the number of rows. So in that case, we can get a general formula for the area. Yeah, I'll just write that in too. Okay, yeah. So once we have this general formula for the area, we can use it to find the area of the or sorry, not the area, but like the value of the 7th oblong number. And we can do this by just plugging in 7 as our n over here. So I'll just move up here, I guess. So f7 is equal to n, or I guess 7 times 7 plus 1, which is 8. And then we can simplify that as 56. Okay, and yeah, that is actually the answer. So we can go ahead and get our answer as 56. If no one has any questions about that, I will continue after I erase everything. Is there a way to erase everything? Clear. Okay, so yep, on to our next slide. I included this slide so that I could explain that there are multiple ways to approach a problem. Am I drawing thing back? Okay, there are multiple ways to solve a problem, and also one strategy to solve any problem in general is to make a process for yourself to follow, so that like a little plan, a mini plan, so that you're not just aimlessly doing calculations or aimlessly doing something, and like, yeah. So I wrote out a problem solving process that we can use here. And this can be applied to any kind of sequences and sequences and patterns problem. Okay, so our first step in the problem solving process is 1, make a table of values. 2, find a pattern and create a rule. And 3, use the rule to find the 7th number, or like your answer in general. So yeah, let's try that. So we have n, and cn, or okay, I'll just do okay, so now that we have this little table, we can go ahead and fill it out. We have 1, 2, 3, 4 so far. We have 2, 6, 12, and 20. Okay, so these are our table. This is our table of values. Okay, so what we can do once we have this is we can think, is it okay? So since it's obviously ascending, 2 is less than 6 and 6 is less than 12. So we can either use addition, or we can try addition or multiplication. So let's try addition first. So the difference between 2 and 6 is 4. So we plus 4 over here, and then plus 6 plus 8. Okay, so over here, if we try this, then we can see, oh, okay, well, it is, we could find the second difference and say that, oh, this is a quadratic, but that seems like a bit much work. So yeah, I'll just erase that. Oh, I can erase it like this. I think actually, like, rather than doing it like this, or actually no, yeah, let's just do it the quadratic way. Oops. So yeah, once you, oh, by the way, so if I think you in grade 9, you know what a quadratic is, right? So yeah, quadratic you would just need to, after you have this table of differences, you would need to find your quadratic. I'll explain how you do that in a later lesson. But yeah, just so we save time here, I think we can just move on. And I think the first method that I showed everyone is actually the best way to solve this problem. So yeah, that would be how you would approach this problem, with the first observation that I gave you guys. So where you can get a general term for the area. So where like this would be n and then n plus 1, or sorry, other way around, n and n plus 1, and then the area would be n times n plus 1. So yeah, that's how you would do it. Alternatively, you could also, with that table of values that I created, since 7 isn't that big of a number, it's not like they're asking for the 2021st number, you could just calculate this by hand, but that is a bit more time consuming than simply doing n n times n plus 1. Just so I think we actually have time for that actually. So I'll go back and term value 1, 2, 3, 4, 2, 6, 12, 20. So yeah, we were adding 4, we're adding 6, and we're adding 8. So the fifth term would be, we're gonna add 10. So this would be 30, and I'll just continue our table up here. So for our next number, we would, since our common difference is 2, you can see that this pattern is 4, 6, 8, 10, and then 12 would go next. So our sixth term would be 42. And our seventh term, we would add 14. So it would be 56. So yeah, that's another way we could potentially do this problem. Again, it is a bit more writing than what I did in the previous slide with like the n times n plus 1. So yeah, that's all up to you, but there are multiple ways to approach these kinds of problems. Okay, next slide. So yeah, I just wrote in the answer over here. The answer is C, 56, as we found with both methods. Alrighty, our next problem is problem 2. And it's from the 2020 Pascal contest, problem 14, so it is quite recent. It's also a part B question, so it's like in the medium difficulty here. I'll go ahead and read the question first. So a sequence of figures is formed using tiles. Each tile is an equilateral triangle with side length 7 centimeters. The first figure consists of 1 tile. Each figure after the first is formed by adding 1 tile to the previous figure. The first 4 figures are shown. And the question is asking how many tiles are used to form the figure in the sequence with perimeter 91 centimeters. So the first thing we would do with this kind of problem is first recognize that we're looking for perimeter. Oh, I need to get my drawing thing. Is that we're looking for perimeter here. So we're not looking for area anymore, we're looking for perimeter. And so the first thing at least that I would do is look at how the perimeter of all these shapes. So we have 1, 1, 1, so that perimeter is 3. And then this perimeter is 4, and this perimeter is 5, this perimeter is 6. And yeah, we also need to make sure to read the question. So each side length is 7. So what I did was count side lengths. We would actually need to multiply all these numbers by 7 to get the perimeter, the actual perimeter. So yeah, let's go ahead and do that. I'll do it in a table. Actually, I'll do it in the next slide after I clear this. Okay. Okay, so now that we have more space to do all these table of values, it's the same thing as the previous process, except a bit more generalized to this and a bit more fitting to this problem. Okay, so we have term and value. One, two, 3, 4. For the 4 terms. So as we found in the last slide, this is 3, 4, 5, 6. So we just need to multiply all those by 7 to get the value, which is the perimeter. Okay, so let's go ahead and do that. The first term is 7. The fourth term, oh wait, sorry, not 7, 21. My bad. 21 and then 28, and then 35, and then 42. Alrighty, so now that we have this table of values, we can go ahead and find our pattern. So let's first try, since it's ascending, let's first try addition. So to get this, we would add 7, add 7, add 7. So from this, we can see that our constant difference is 7. And so when we're writing a formula, Fn, we would need to have 7 times something. Yeah, and just to go back to the first term here, we would see that the term number is 1, but we're actually multiplying 3 times 7. So to get from 1 to 3, we would need to add 2. And same thing was like looking at any other one. This is for this second one. It's the second term, but the perimeter is 4 times 7. And to get from 2 to 4, we need plus 2. So if we see this kind of pattern, we can go back over here to our formula and say that this should be n plus 2. Does that make sense to everyone? Okay. I'll just erase this part since we don't need it anymore. And if you guys don't understand anything, or if I'm going too fast, too slow, just let me know. Okay, so yeah, now that we have this formula, just a reminder, this formula is for the perimeter. So now that we have this formula, we can use it to find how many tiles are used to form the sequence. So just as a reminder that, oh, sorry, okay, I should have drawn this arrow like this. This Fn is the perimeter, and this n is the number of tiles. Okay, yeah, so that's the number of tiles. So now we can use this to find our answer. I'm just going to erase a bit more that we don't need to clean this up. Okay, so now we can plug this. Since this is the perimeter, we want to actually, instead of putting this into the n position, we want to not do this. We want to put it into this position since it's the perimeter. So in that case, we would do 91 is equal to 7 n plus 2. And so 91 divided by 7 is 13. I believe on the Pascal, you guys are all allowed calculators. So if you guys can't do, if you guys don't want to do mental math, that's all good. But mental math is quite important for contests, especially if it's something small. You don't want to always rely on your calculator to do everything. So now just solving for n, subtract 2 from both sides, n is equal to 11. And that is actually one of the answers. So yeah, this problem, we would conclude that the answer is 11. And yeah, so the answer is indeed B. Let me just erase everything and also drink water. Okay, on to our final question. Get my drawing tool. Okay, so yeah, this is our last problem for today. It's from the 2011 Pascal and it's problem 21. So as you guys might know already, 20 to 25 is part C, so it's a bit more difficult than part B questions. Of course, this can be subjective, so always make sure to try all the problems if you have enough time. Don't go, oh, if you're stuck on one question in part A, don't spend too much time on that. Continue to other parts, and yeah, just make the best use of your time, because questions aren't always ranked in order of difficulty. In general, they are, but maybe you don't understand, maybe you don't see the pattern immediately, and you can come back to it later. Then you can get your points there. So yeah, problem 3, it's from Pascal 2011, problem 21. I'll give it a read. Okay, so in the diagram, there are 26 levels labeled A, B, C, all the way to Z. There's one dot on level A, and each of the levels B, D, F, H, and J, all the way to Z, contain twice as many dots as the level immediately above. Each of the levels C, E, J, I, K, all the way to Y, contains the same number of dots as the level that's immediately above it. how many dots does level Z contain? You're given some options and you're also given a diagram. And this diagram, we're going to use it. Whenever you're given a diagram and it will help you, go ahead and draw on it when you're writing the contest. Let me just change slides. Okay, I have another problem solving process that we can follow. First, we want to sketch the diagram. They've already sketched it for us, so that's awesome. We can add on to theirs, and we can make any kind of notes that we need to on that. Our next step is to find a pattern from from the diagram that we just drew. And our last step is to use the rule to solve. And like the rule that we found, any insight that we have found from the pattern, we can use it to solve our problem. All right, so I'm just going to use the diagram that they gave us. I'm going to add on to it. So this is level E, this is level F. So since this already stayed constant, this will double. And then for G, as always, during a contest, if drawing a diagram helps you, you guys should draw a diagram. But if not, don't waste your time, because the only thing you're submitting is your multiple choice answers. So if you guys don't need to provide any work at all for the Pascal. So yeah, don't waste your time if you don't need it. But in this case, it'll help us. It'll help us find the rule. Okay, so now I want to do a little thing where you count how many dots are in each. 2 and then 4. We have 8. Wait, 1, 2, 3, 4. Yeah, 8. Okay, so as you can see, that we can already see a pattern forming, or at least I can. And hopefully after all these courses, and after we do a lot of practice, you guys can also see a pattern immediately. So what I see over here is that these are all powers of 2, and that also these the powers of 2 are repeated twice, except for the one up here. So if we continue this pattern, we can see that it just doubles every other, that the numbers double every other level. And so since there are 26 letters in the alphabet, and there are 24 levels after B, since B is the second letter of the alphabet, I'll just write this out. So 24 levels after B. And then you also know that the number doubles every second. You know that the number doubles every second level. Number doubles every second level. Since you know this information, you can conclude that if you divide these two numbers, then you'll get the number of times that you'll have to multiply by 2. Or the volume. Okay, so now that we have this, the division sign, we can actually solve the question, since we know that how many dots are at level B, which is actually, yeah. I will erase this. And redraw that sign. Okay. So this is how many times we need to multiply by 2. And yeah, so we have the so therefore the level Z has 2, which is the number of dots that B has, times 2 12 times, since it doubles 12 times. And that's equal to 2 to the 13. And 2 to the 13 is equal to 8192. So yeah, there we have it. That's our answer. And as we can see, if we go back to the options that we have for our multiple choice question, the answer is one of our answer is actually one of their answers. Also, just one more tip for this. If you get the same answer as one of the answers that they give you, it doesn't always mean that it's correct, because these answers that they give you, they also account for different mistakes that you could have made. So don't always trust your answer, and don't try not to guess. Or actually, no, guessing is a pretty good strategy. But yeah, just be careful. Even if you got the same answer as one of their questions, one of their answers up here, doesn't mean that it's automatically correct. But it does feel good if you do get the same answer as one of them. So yeah, anyway, our answer over here is D. So yeah, I'll change slides. Actually, I'll clear my slide first. Okay. Okay, and yeah, that's it. That's all I have for everyone today. I'd like to open the floor to any questions. If you guys have any, you guys can always put them in the chat. And yeah, I'll be monitoring that. So if you guys have anything, please write it now. Yeah, and I'll wait for a minute before passing the time off to Jack. Oh, actually, never mind. Jack is doing it. My bad. Okay. Yeah, in that case, I'll pass the time off to Jack. Okay. Oh, okay. I'm not sure if Jack wanted to wrap up the class, but if not, I hope to see you guys all at the next lesson. Yeah, so I hope you guys have a wonderful week, and I hope you guys enjoyed the lesson for the first lesson. If you guys see on our class on the screen that Jack is sharing, it's all the directions you guys will need to join the class and register.
Yes, so Jamie, thank you very much for your work. Yeah, you give us a very excellent class. So if anyone are interested in the Pascal class, yeah, please send an email and transfer the tuition to canadaolympiad@gmail.com. Jamie did a very excellent job. He touched the very challenging topic. It's called sequence and patterning. So this is the University of Waterloo's mathematics contest 的 favorite topic。很多人就问我，那么你们的家长就问我是不是要刷题啊什么玩意儿的？其实刷题其实并不重要，关键的是呢，要像 Jimmy 这样子，他能够从那个做题目中呢，能够进行总结反思，找到规律。那么为什么这个题型为什么重要呢？它就是考了你2种能力，一种是演绎，一种是归纳。那么首先是归纳呢，你能归纳出一个 general conclusion。比如说，你能 find a general item formula, and then you have to apply the general conclusion to get the specific items. For example, you have to apply this general items formula to get the value of some specific item, or apply the pattern you detected to get the value of the expression or prove something. So this is a very tough task, but Jimmy did a very excellent job. He summarized the procedure step by step and teach you one by one. So Jimmy is a very excellent teacher. I hope you can follow Jimmy to save your time to improve your mathematical skill to get the excellent grade in the Canadian contest. Okay, do you have any questions? Okay, if you don't have questions, today's class is over. Jimmy, thank you so much for your help.
Yeah, no problem.
I will get in touch with you. So how can I contact with you? Can I call you?
Sorry, I was muted. Yeah, sure.
Yeah. Can I call you after a while?
Yeah, definitely.
Okay. Sure. Okay. See you soon.
See you.